Good morning. Today we are doing lesson 8.2, which is our second day of simplifying exponents. Today we're applying exponent properties involving quotients. So this word of quotient right here is another word for a fraction or division. So that word quotient means divide. Yesterday or the other day we had product, meaning multiply. So here we're going to simplify this quotient or this fraction. So on the numerator, in the numerator here, we have 8 to the power of 10, which is 8 10 times. So I'm going to write out 8 10 times. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the bottom I have 4 8s, 8 to the power of 4. So if we think back to last year, the year before, 6th grade, 5th grade, we learned maybe that 4 divided by 4 is really just 1. 4 goes into 4 one time, just like 8 goes into 8 one time. So 8 divided by 8 is really just 1. So if we have 8 divided by 8 right here, this is really 1 times 1 times 1 times 1. 1 times 1 times 1 times 1 is just 1. So we have 1 times this many 8s left over. We have 1, 2, 3, 4, 5, 6 8s left over. So we have 8 to the power of 6. Since this is a fraction that technically is on the top, but we really have 1 times 1 times 1 times 1, which is really just 1 in the denominator. So anything divided by 1, this is still really just 8 to the power of 6. This doesn't change our answer. Let's do the same thing on this next one here. We're going to write negative 3 5 times. Negative 3, negative 3, negative 3, negative 3. On the bottom we have negative 3 3 times. These are touching, it means it's all multiplied. Since we have only multiplication and division, we can simplify. 3 divided by 3 is just 1, so this is really 1 times 1 times 1. We have 2 negative 3's left over. On the bottom we could put divide by 1. It doesn't change our answer because we really just have negative 3 squared to the power of 2. This next one we need to be careful with. We have 2 5's on the top here. We have 5 to the power of 4. So we have 4 5's first. Then we have 8 more 5's. 1, 2, 3, 4, 5, 6, 7, 8. On the denominator we have 5 7 times. 1, 2, 3, 4, 5, 6, 7. And we know 5 divided by 5 is just 1. So this is really 1 times 1 times 1 times 1 times 1 times 1 times 1. So we really have how many 5's left over? 1, 2, 3, 4, 5. So we have 5 to the power of 5. Again, if you want to put it over 1, you can, but there's nothing on the denominator left over, so our answer is 5 to the power of 5. Now this last one we need to be careful with, because this first part's a fraction, but the second part is not. So if 1's a fraction, we need to make both fractions. So to make it a fraction, I'm going to divide it by 1. So we really have 1 times x to the 6th in the numerator, because this is really on the top of our fraction, which is really x to the 6th. X to the 4th times 1 is really just x to the 4th. And then we can write this out however many times we see it. We have x to the power of 6. 1, 2, 3, 4, 5, 6. If you want to put the dot in there for multiply, you can. On the bottom we have 1, 2, 3, 4 x's. So if we simplify, x divided by x, just like 5 over 5 is just 1, so we have 1 times 1 times 1 times 1. We have 2 x's left over, so we really have just x to the power of 2. There's nothing on the bottom, it would just be a 1. It's really just x squared still. If there were more x's left over on the bottom, you would need to leave it on the bottom of your fraction. Alright, now just like the other day, if we learned x squared means x 2 times, whatever's in parentheses, our exponent still tells us how many times to write this. I'm going to put the negative with the 5 but pick whether you want to put it with the 5 or the y. I just always like to put it with the number or the top number. So we have negative 5 over y. I'm going to write this 3 times. Negative 5 over y, negative 5 over y. So overall, we have negative 5 how many times? Well, we have negative 5 times negative 5 times negative 5 3 times. And the denominator we have y 1, 2, 3 times, or y to the third. So this is our answer. So on our next one here, again, we're going to write whatever's in parentheses, whatever the exponent says 2 times. So again, I'm going to put the negative with the 7. So it's negative 7 over x 2 times. Negative 7 over x. So how many negative 7s do I have? Well, I have negative 7 2 times. Again, I put it in parentheses because it's not 7 times 7, it's negative 7 times negative 7. Then on the bottom, x times x is x squared. Sometimes we evaluate the exponent if it's less than like 3. So if you want to multiply negative 7 times negative 7, makes a positive 49. That will give you an okay answer as well. I would accept either of these answers. Same thing here, we're going to write whatever's in parentheses 2 times. A over b, a over b. Now I know there's 2 a's, so not 2a, but a times a is a squared, and b times b is b squared. That's our answer. This next one's like one we did on the first page, where if one's a fraction, we need to make them both fractions. So we really have 1 times 7 squared, and the numerator is really just 7 squared. 7 to the third times 1 is still 7 to the third. So if you want, write it out however many times it says. This one's 2 times, and this one is 3 times. So we have 7s on the top and the bottom. If you ever have the same thing, we can cancel them out. 7 over 7 is just 1 times 1. So we only have 1 7 left over on the bottom. So on the top, you do need a 1 to show that it's 1/7 and not 7. Those are very different answers. All right, again, whatever's in parentheses, we write it 3 times here. X over y, x over y, x over y. So we have x 1, 2, 3 times, x to the third, and y 1, 2, 3 times, y to the third. Last one, like this, we have 7 to the power of 4, so 7 4 times, 1, 2, 3, 4 7s. We also have 7 3 times, 2, 3. And in the denominator, we have 7 5 times, 1, 2, 3, 4, 5. So if we simplify this, 7 over 7 is just 1, just like we did up here, times 1, times 1, times 1, times 1. We have 2 7s left over. And so our answer, we have 7 to the power of 2 on the top, and on the bottom we just have 1, 1 times 1 times 1 times 1. And that's really just 7 squared. All right, flip over to the back side. We've got a couple more. A little bit more going on in these ones, but we still know how to follow the same strategies. We're going to write this all 3 times. So we have 4x squared over 5y, 4x squared over 5y, 3 times 4x squared over 5y. And now we're going to count up how many we have of each. If you would like to write it all out, this is really a 4 and 2 x's. This is really a 4 and 2 x's. And this is really a 4 and 2 x's. In the denominator, we have a 5y, a 5y, and a 5y. If you don't need to write that out like that, that's okay. But it sometimes is helpful to see really how many of each letter and number we have. So in the numerator, our numbers we have 4, 1, 2, 3 times, or 4 to the third. Then we have x 1, 2, 3, 4, 5, 6 times, so x to the power of 6. On the bottom we have 5, 1, 2, 3 times, so 5 to the third. And then last we have y 1, 2, 3 times, y to the third. So this would be our best answer. Sometimes, for example, in the MCA, they might multiply 4 times 4 times 4, but either one I would accept. Alright, this next one, same thing. We're going to write whatever's in the parentheses 2 times. So x squared over 4y, x squared over 4y. Now this one, if you want to write it out as one big long problem, you can, but I know that x squared is really x two times, so really I have x to the power of 1, 2, 3, 4. There's 4 x's really on the top. On the bottom I have 4 times 4, or 4 squared, and on the bottom the y times y is y squared. This is a great answer. However, if you multiply 4 squared, 4 times 4 is 16, so you could write this as well. Either one would be correct. Alright, last one on this slide. Simplifying. We're going to take it one piece at a time. This piece has an exponent of 2, so I'm going to write it out 2 times. 3x to the third over 2y. 3x to the third over 2y. 3x to the third over 2y. Oh, I only needed it 2 times. Silly me. The exponent was a 2, so Rachel, you only need 2 times. And then we have this 1 time, 1 over x squared. So since this is all multiplication, this is really one big multiplication and division problem. So I'm going to write this out. If you don't want to write it out like this, that's okay. We have 3 and x 3 times, because there's a x to the power of 3. Then a 3 and x 3 times, and then times 1. On the bottom I have 2y, and x 2 times. So the reason why I wrote this all out is so that I can see we really have x's on the top and the bottom. So it doesn't matter which ones cancel out, but 2 of them need to go away. We don't have any y's in the numerator and the denominator, so they'll stay the same. So I'm going to do my numbers first. 3 times 3 is 3 squared, or 3 times 3 is really just 9, and 9 times 1 is still just 9. Then I have 1, 2, 3, 4 x's left over, so x to the 4th. The other ones got canceled out. We have 2 times 2 on the bottom, which is 4. You could leave it as 2 squared if you'd like. And then we have y squared on the bottom because we have y and y. So this is our answer. Alright, the last piece of information is if we have an exponent that is a 0. So for example, I'm going to do this one first. We have x to the 6th over x to the 6th, which is really, we could write this out 6 times and 6 times. They would all cancel out, 1, 2, 3, 4, 5, 6, and leave us with nothing, or really 1 times 1 times 1 times 1 times 1, which is really just 1. If you think back to our exponents we did earlier, if we had 8 to the 10th over 8 to the 4th, we ended up with 8 to the power of 6. We just subtracted 10 minus 4 gave us 6. There were more on the top, so it's on the top. So here, if we subtract our exponents to get to our answer, 6 minus 6 is 0, so we'd really have x to the power of 0, which is really 1. So if you plug this into your calculator, 4, this up arrow means to the power of 0, it will give you the answer of 1. Because we really have the same thing on the top and the bottom, there's none left over. There are 0 4s left over. They would all get canceled out, so it's really 1 times 1 times 1, which is just 1. Same thing if it's a letter. Anything to the power of 0 is 1. Don't let this confuse you. This whole piece right here, I don't care what's in here, it's to the power of 0, so this is just 1 times x to the 7th. Well, 1 is just 1. 1 times x to the 7th is really just x to the 7th. Because this whole piece was just 1 out front. Alright, the last 3 are missing exponents we need to simplify. So we know we need to get to 8 to the power of 3. Oops, I'm going to erase this for a second. I know I need to get to negative 8 3 times. They told us we have negative 8 7 times. So 1, 2, 3, 4, 5, 6, 7. I know that's really small there. But they told us we have negative 8 7 times. We need to figure out how many more do we need on the bottom to get to an answer of 3. So I know I need 3 left over, so I need to keep like these 3 here. So I would have to have 1 on the bottom to cancel out there, 2 to cancel out there, 3 to cancel out there, and 4 to cancel out there. So how many negative 8s did I really put on the bottom? Well, I put 4 negative 8s on the bottom. So my missing question mark, I needed 4 negative 8s on the bottom to leave me with 3 left over. Let's try the next one, same thing. We need to get to x to the 7th. So we need 1, 2, 3, 4, 5, 6, 7 x's left over. This is what we want our answer to be. We know that there are going to be 5 on the bottom that go away. So 1, 2, 3, 4, 5 are going to go away with some other x's up here. So think here, we needed these 5 to go away, 1, 2, 3, 4, 5, in order to leave us with 7, because we wanted 7 left over. So we had 5 on the bottom. How many did we really need on the top? So we need to count up all of the ones we have on the top to figure out, okay, how many total on the top? Take away these 5 would leave us with these 7. Well, we had 7, and then 8, 9, 10, 11, 12. So we would have needed 12 x's on the top. 5 of them would have canceled out to leave us with 7 left over. Alright, this next one is similar, but I'll take it a little bit slower this time. I'm going to draw my fraction out just like they have. They know we have 4 7s on the bottom. 1, 2, 3, 4. So we took care of that. We need to figure out how many are we going to put right here. And then we have 2 more. Took care of those. And we need 6 left over. So we only have 2 right now. So we need 6 to be left over. And we know these ones are probably going to cancel out because there's nothing left on the bottom. So we need 1, 2, 3. So we have 1, 2, 3, 4, 5, 6. So we could leave these 6 to be left over. That's what we want in the end. But none of them canceled out yet. So we need 4 more 7s so that these can cancel out and leave us with 6 left over. So how many did I really add to the top? Well, I added these 4 over here, 1, 2, 3, 4, and I added these 4 over here, 5, 6, 7, 8. So that question mark right there, I really needed 8 7s total. I know it's a little confusing why I put them on either side, but they told us these 2 are already there. The red ones were already there. So we had 7 squared already. We knew we had these 4 on the bottom, so those ones had to be there. We need to figure out how many more blue ones do I need to add here to get 6 left over. And I needed to add 8. Alright, your homework is a worksheet. You have to write whatever's in parentheses, whatever the exponent is. It tells you how many times to write it, and just simplify. Good luck.